What'd you guys just hear her say? Did you guys hear her?
Recording in progress.
Yeah, that's new, isn't it? I don't know. I think
It's done that every time.
for me, it said something different before. It would say, oh, anyway, it's okay. Could be I just did too many shots over spring break, but I think I have recovered. All right, let me see. Oh yeah, I sure am just washing off Bryce Canyon. Let's see. Turn that off. Okay, so we're gonna look at number 48 from section 7.2 because I agree. And all I'm gonna do for you is help you set this up, help you draw this, right? It's up to you to actually work it out. So what's it say? It says a 200-foot tall monument is located in the distance. Sorry. There you go. 200 feet. Okay, let's just go 200 feet. All right. From a window in a building, a person determines that the angle of elevation to the top of the monument. Okay, so now we have this building, and somebody's in some window somewhere. Doesn't matter. Here they are. Professor Stick, right? A person determines, and now listen, this is going to come up a few times. All right. We have this idea of, now stay with me. This is a huge note to take. This is going to come up in a lot of these trig problems. We have the idea of angle of elevation and angle of depression. They're always measured with respect to horizon, right? Looking straight forward. Angle of elevation is the angle up from that straight forward. Angle of depression is the angle down from that straight forward. So if this guy, if he's looking straight out, parallel to the ground, the angle of elevation to the top of the monument is 18 degrees. And the angle of depression to the bottom is 3 degrees. Now, obviously, my picture is not the greatest, but it's not too far off. How far is the person from the monument? I love this problem. Wait, did I mix up two things? Yes, I did. Jeff, sorry. Number 49 is almost the same as number 48. I'm looking at 48, right? Yes. So it's 15 and 2. Okay. So I'll give you a big time hint here. Trigonometry is based on what kind of triangles?
Right angle.
Take it that you're saying a right triangle, not calling me a loser. So you always want to see, can I find the right triangles in the problem they've given me? And yes, you can. Now, the next thing is, how do I don't want to give too much away. So this thing is 200 feet tall, right? What is it you're trying to figure out from this problem is how far is the person away from the monument? You're trying to figure out this. So this is the distance. Let me call it D. This is what I'm trying to figure out. I want to know what that distance is. You know, this total distance here is 200 feet. But how does this fit in to the triangles, the right triangles that you see? What does this have to do with the right triangles that I see?
It's divided by
Okay.
the view somehow.
Way. And I have no idea how much goes on and where. So how long is this? Does anyone know?
X.
Good. We don't freaking know, right? Shit. But then how long must I say this is, considering that I know this is 200 total?
200 minus x.
Yes. All right. So now can you write expressions for D related to, can you write an expression for D from this triangle in this side and from this triangle in this side? You're going to make like a system of equations. It's really neat. So for example, I don't know, what trig function relates this angle with these sides, this triangle?
Sine.
No.
Tangent.
Yes, because where's the right angle? Here. So that's the hypotenuse. I don't know anything about the hypotenuse, so I would never use sine. Right, so I want to use, so what, tangent of 15 equals what for this triangle?
X.
Keep going. It's a ratio.
X over
Function is a ratio.
D.
Yes, x over d. So it's the y side over the x side. And you're going to have to let go a little bit that sometimes you're going to call something x when it's actually on the y side. You're just going to have to work with that. So it's this side divided by this side, right? Can you write a similar expression for this triangle? Relating these two, the side that you want to know something about and the side that you do know something about? Yes. Then you can solve between those two equations, you can solve for D. Believe it or not, you can. Can you solve this one for X? Yes. Can you then put it into the other equation? Yes. Then you'll only have the D variable in the equation. Yes. Then you can solve for D. Yes. Okay, you're done. Yay. All right. But if hopefully the picture, because I agree with you, it's kind of weird when you read this. They're not as specific with how things are kind of oriented.
Yeah, I actually drew it the right way the first time,
Oh, cool.
but then I was measuring the wrong part. I was measuring the floor.
All right.
Like I drew a dotted line and made the right triangle the very bottom.
Did you have the angles in the right kind of place?
Yeah.
All right, good.
Yeah,
So
I was
normally
just
it's the
drawing.
angle of elevation depression that people are confused.
Yeah, I was just drawing that awkward triangle that's underneath him.
Oh, here.
Yeah.
All right. That really doesn't. Yeah. Okay. Doesn't help you. Okay. Anything else, guys? What I kind of want to do is something we haven't done much of yet, and it's funny that it's in this problem, but I want to take a step back from this problem, especially because it's been over a week, right? So let's take a look at a much smaller scale problem that deals with something we had to do in that problem, which is namely, can you figure out all the sides of this triangle just by me giving you this information here? Can you figure out these two sides of this triangle? And if you've done some of the homework, you've seen this problem in, I think it's 7.2, I'm pretty sure, right? So how the shit do I do this? One thing I desperately want you to remember, always remember this, no matter what you're doing with trig. What are the trig functions based on? What are they fundamentally? What are trig functions? I love that question, so open-ended, but the most fundamental definition of a trig function is what?
A ratio of
Ratio
sides of a
of
triangle.
Sides of a triangle. Shit. It's almost like I planted you out there. Yes, this is a huge note to take. So this is a kind of problem that trig functions just eat up. That is the most basic use of a trig function, is this. So for example, what is tangent of 27 degrees? What would that be in this triangle? You're dying. Go away.
11 over A.
I'm not sentimental about my markers at all. 11 over A, I love it. Is everybody with me? At this point, if you do not know the ratio that tangent wants from you, that's a bad thing. You got to know that. And I know it's been over a week since we did this, You got to know your trig functions. You got to know which ratios they want from you, right? So tangent wants y to x. And then here's a little cool thing, algebra thing that I was talking with somebody about earlier. These can just switch. You can multiply the a up and divide the tan down. Now, can you plug this in your calculator and tell me what the hell that is? Where's my calculator? There you are. What should they be careful about, Jordan?
Parentheses.
No, was it you that did this earlier or somebody else?
Yeah, we were talking about it. I just gotta make sure that the function stays the word tan.
No, you
Right.
got to make sure that you're in what?
Oh, degree.
Yeah, in this case, you have to be in degrees, right? So let me talk about this. What do you guys get when you plug this in your calculator? If you're currently logged in, make sure you can get this answer correct. So can somebody tell me what they get when you plug this in your calculator? Anybody? Yeah, I like it. So about 21.59, if I round up to the hundredth place, 21.59. I didn't give it any units, so that's fine. Is anyone not able to get that? So real quick, I don't think I've talked about this specific thing yet. So let me show you in the calculator how to do, how to change it from degrees to radians. Here we go. Come on, calculator. Here we go. So right here under mode, right there, that's how you go from radians to degrees and vice versa. So you can switch over to degrees. So now when you do 11 divided by tangent 27, it knows it's in degrees. So what if I had mistakenly been in radians? Let's see what I get when I put 11 divided by tangent 27. I get something that doesn't make any sense. Do you guys agree? So this is what I meant. Normally you can tell you're in the wrong mode because something about the problem is going to be off. But you can design it so that it actually doesn't give you that hint. Anyway. All right. Is everybody doing okay out there? I mean, I really need you to really understand the basics of the trig functions, what the ratios are. And this is the most fundamental kind of problem you can use for trigonometry is, if I give you one side, can you figure out the other sides with one angle? Yes, that's what trig functions are built to do. That's what they kind of fundamentally exist for. So how do I get B? What am I going to use for B?
Cosine.
You could use cosine.
Or 11 squared plus a squared
Oh, yeah.
equals
You
b
could
squared.
use Pythagorean theorem. I love it. I would use either Pythagorean theorem, but I would actually use sine. Because is this the exact answer?
No.
No. But if you did use Pythagorean theorem, I'd have no problem with that. If you did use cosine, I'd have no real problem with that. But this is rounded. So in our future, we're going to have problems that are like solving a triangle, and they're going to be a little bit worse than this. And you pretty much always want to go back to the things you know definitely are that, like the 11. The 11 is a beautiful thing. It's exactly 11. You want to use it when you can, because there's nothing unknown about it. It's 11. This is not 21.59. It isn't. Okay, I like it. It's not that far off, but
Did
so
you
I would
also
rather.
find the other degree, the 63?
Oh, you can. Yeah, that doesn't matter. Yeah. All I want are the sides. But yeah, you can find that real easy. So how would I use sine? What's sine of 27? What's sine of 27?
11 over B.
11 over b, right? It's the y side over the hypotenuse. And then you can do the same thing we did up there. You throw that in the old calculator. Okay, I like it. All right. You guys doing okay out there? All right.
There was something funky about the first section or the first the problem in 7.2, number 10. Because I could get some of them like pretty easily by doing normal math like we just did. But for some reason, number 10 threw me for a bit of a loop.
Oh, okay, okay. So let's see if we can draw this bad boy out. All right, let me do it on here. So one thing I need you guys to know is when we're using stuff like A and B, well, they tell you right here, fantastic. Because I haven't had to say this yet, but we normally use lowercase letter for sides. And then for the angle across from that side, we use its uppercase equivalent. Are you guys all with me? All right, so this triangle, side C is a hypotenuse. Holy shit, Jeff. All right. All right, fine. It's okay. Let it go, Jeff. It's all right. Let's see, where am I at? So we know that if I put B here, cosine of B. So where's little b?
Across from it.
Yeah. And then this of course would be A, and this would be little a. All right. And what do they tell me? They tell me the cosine of big ass B is 4/5, and they tell me that A is 10. So, I mean, so what does this here tell you?
It's a ratio.
Sure.
Is it a ratio of 10 though?
No. Come on. All right. Let me take that 10 away for a second. Let me take that 10 away. All right. What is the cosine of B just from the triangle? Just looking at the triangle. What's the cosine of B? Let me
A
put
over C.
let me put little c over there. Yeah. It's A over C. I like it. And they tell me that cosine of B is 4/5. Right? Does that mean that A is 4 and C is 5?
No.
No, it means that this reduces to this, which is why they also have to tell me that A is 10. Now, can you throw that bad boy in and solve for C? What's happening?
I think I get like 50 over 4.
Yeah, nothing too pretty, right?
How would you plug that in?
Well, there's A, and I know A is 10.
Right, but you
10
can't.
over C equals 4/5.
Oh,
I know that cosine.
I was like, you can't plug a B into a calculator.
All right, true. But this is, so cosine of B identifies a certain ratio, and then give me the value of that ratio. So I see you're trying to force this into a problem where you have to do trig in the calculator, which is not the point of the problem. The point of these problems is getting used to the ratios that the trig functions relate to. Does that make sense? Yeah, this is not really anything to do with actual values of angles. They don't care about the angles in this problem. And once you have side B, you can very easily figure out what side C is. You guys okay?
Yeah,
out
okay.
there? I mean, let me know. You got to let me know if this is not making sense right now, because this is the building blocks of this stuff right here. Let's try another problem out. Look at number 11. take a minute, try to draw that triangle out. And what I would highly recommend is sort of like what I did with this triangle was I didn't put the value of A in the triangle yet. So you can pretty much just use this setup. And then they tell me sine of B. Right, so what is sine of B equal to from the triangle?
B over C.
B over C, because sine likes Y. Sine is the Y over the hypotenuse, so I like it. And they also tell me that sine of B is 1/2. So now I've got this equation. And then they tell me, now what's really horrible about this is they tell me that A is 20. So how can I, what can I do? How can I use this information? How, because there's no A in this equation, right? What else do I know about a triangle, about a right triangle? What else is true about A, B, and C? Little a, little b, little c.
The Pythagorean theorem.
Pythagorean theorem, I like it. So I know A is 20, right? Now, why does that kind of suck? Why does that suck? You can just tell me, Jeff, that's whoop-de-doo, but that sucks. Why does that suck? Why does it still suck? Let me see.
We have to substitute to find one of the other variables.
Yeah, I don't know what B or C are. So how the hell, once I plug a 20 in there, okay, 20 squared is 400. You could then look at me and say, good job, math boy. But I've got this information. So a lot of what we're going to see, something that's going to show up a decent amount is the idea of substitution. The idea, it comes from system of equations, right? Systems of equations. So can't I kind of like cross multiply this and get C as 2B? Is that cool? You guys see that? And if C is 2B, that means I can plug 2B in place of C, and then I can solve for B. Are you guys understanding out there? Are you guys okay out there? All right. Okay.
So now we plug in 2b into the Pythagorean theorem.
In place of C, yeah. There is another way to do this problem, but I'm not gonna, I think I'm gonna stick with this for now. I'll let other people try to be creative. There's another way to do this problem that's a little bit, has smaller numbers, but that's all it's got going for it. This method definitely works pretty nicely and directly. How does, please, you guys have to help me out here because I can't see everybody. Everyone give me a thumbs up if you're okay with what just happened. Like a, there we go. If you don't have your video on, you know how to do a thumbs up, everybody? All right, anybody that doesn't show me a thumbs up is gonna make me concerned. Okay, I like it. I got some hands raised. I got some check marks. Sure, I'll take it. So everybody who's not showing me anything, are you there? Hey, there's somebody. Okay, I like it. All right. I just need some kind of sign that you're there. Okay. Somebody's having a party.
Not cosine?
I like it. Sorry?
I was making a joke. You said you need a sine, not a cosine?
Oh, shit. That was a good joke. Sorry. All right. All right. All right. I like it. Because this is a fundamental, straightforward thing that helps you. If you understand these problems, the word problems are a little bit easier to handle. All right. Let me make sure. Did you have a question or did you just, you didn't know how to
do a thumbs up. Is that what happened? Let me see. I'm gonna lower your hand. Bam. Okay. Okay. Anything else from homework, guys, before I?
How do you reduce? So if we plug in the 2b squared, how do we reduce from there?
So you get 400 plus b squared equals 4b squared, right?
Mm-hmm.
All right. So you subtract b squared, divide by 3. I don't know. I'm doing a couple things. Is that all right? Subtract b squared, so you get 3b squared. Divide by 3, so you get b squared square root. Done.
Oh.
Yeah.
Because 4b squared minus b squared is 3b squared.
There you go.
Okay.
So as always, the variable you're trying to get isolated, you get it all on one side together, and then you divide all the shit you don't want. And in this case, it's still inside of a square, so we kill it with the square root, right? The squares don't care about fire. You can't kill them with fire. You can only kill them with square roots. Laugh.
And
So
14 was probably the grossest of that whole section.
ooh, so I'm going to leave that one alone, you guys. Ha ha. You guys try it out. Sorry, something to look forward to if you haven't tried these things out yet. If you'll notice, 11 and 14. So Austin, I don't know if you're like, man, I wish you would have shown me freaking what we just did, because 14 is basically the same problem as 11 with this more disgusting numbers.
Yeah, I see it. Like,
Yeah.
yeah, and I might just have
So-
to substitute something for some of the ugly stuff and then put it back in later.
Oh, okay. That's a great thing. Like the AB thing, like the U sub thing. Yeah. So the U sub idea is really, really useful. I like it. So you can use it basically anywhere you want to. Yeah. Okay. Anything else from homework before we get back in? All right, let me see. Let me see if there was anything else weird. I don't think too much of this is weird. These are just visual representations of the same kind of problems. Yeah, so this should not be too horrible, I don't think. Oh, here's where things get a little more interesting. Let's try one of these, like 43. This is a little bit related to that building problem we just did on the board earlier.
Just turn sideways.
Turn sideways? How do you mean? Oh, I see what you mean. All right. And again, the whole thing with trig functions right now, by the way, a little teaser for you guys. I think I might have told you this. Did I tell you that I'm going to show you a version of the Pythagorean theorem that works even if it's not a right triangle? Have I told you that? We are going to learn. There's
You mentioned
one.
it.
Cool. There's one term that I put onto the equation and it works for any triangle at all, not just right triangles. So I don't know. Hopefully that's cool to somebody out there. But for right now, we can only deal with right triangles. So it should be pretty obvious in 43 where the right triangles are. So I'm trying to figure out what this entire side length is. But I'm going to break it up, right? I'm going to break it up into, let's call this, doesn't really matter. I'm going to call this one A, and then this will be X minus A. Is that cool? You can do this a few different ways. So now what can I set up for this triangle here with the 36-degree angle in it? What side do I not give a shit about in this triangle here? Which side does not matter to me?
The hypotenuse?
Yes, the hypotenuse. It's not something I know anything about, and it's not something they're asking me about. So I do not give a shit about it. So I always have somebody who takes the time to try to figure this side out. I'm like, you are just wasting time. So I'm really loving this side for both triangles. And then of course I have to be interested in this side because it's related to what they want me to find. So that tells me which trig functions to use. am I going to use cosine or sine or either one of those?
Not likely.
No, because I don't care about the hypotenuse, right? And those both have hypotenuse in it. So what can I set up for 36? And how does that relate to the sides of this triangle? So which trig function do I want to use? Yeah. I could use cotangent too, but we mostly stick with the big three: sine, cosine, and tangent. And what does that equal?
85 over A.
85 over A. I like it. And what about this other triangle? So here's one equation I can set up.
Tangent.
Yeah, so tangent of 50 equals,
85 over X minus A.
there you go. I like it. So this one you can solve for A, and then you can plug it in here and solve for X, right? Do you guys see that? Really want you to understand. So I think this book is a little bit flipped around. We're going to do like a review of systems of equations later, and we're going to get into systems of 3 equations and then matrices. Yes. But systems of equations show up definitely big time here, right? But it really is just substitution. But you have to set up 2 equations and then use one of them to plug into the other one. It sort of feels like a tell me, ask me thing. Okay, maybe. All right. So I'm going to clear this away. So what I want to focus on tonight is actually here. We've already talked about the unit circle. I sort of did things a little bit in a different order than the book did, but something we haven't really focused on is what you're going to have to memorize and how does it apply to other quadrants. All right, what the shit am I talking about? So we've already talked about the first quadrant. In fact, I don't know if you guys remember, I tried to show you a way to remember, not remember, but a way to see how the cosine builds or the sine builds. Let me see if you guys remember. So I tried desperately to show you how sine, what was sine of 0 degrees? What is sine like? X or Y?
Y.
That's right. Sine likes Y. I like, all right, trying to do something. So what's sine of 0 degrees then? How much is this have a Y piece? How much of a Y piece does this have?
None.
None. So that's obviously 0. And then I talked about how that builds as you go up to 30 degrees, 45 degrees, 60 degrees, and then of course, 90 degrees. So who remembers what sine of 30 degrees was? It slowly builds up.
Root 3 over 2.
No, you went too big.
1 over.
Yes, this is 1 over 2, which I called, so I call this one square root of 0 over 2, square root of 1 over 2. So what's sine of 45? I don't know if you guys remember this? Sorry?
Root 2 over.
Root 2 over 2, I like it. Root 0 over 2, root 1 over 2, root 2 over 2. So this is going to be root 0 over 2, root 1 over 2, root 2 over 2.
3.
3 over 2.
Root 3 over 2. Okay. It's like everybody getting silent when the chorus comes on. I'm like, come on, what the hell? And then of course, this one is for 2 reasons. How much of this is the unit circle, remember? This is all built on the unit circle. So how much of this is a Y piece?
The whole thing.
Whole damn thing. So of course the sine of 90 is 1 because the whole damn thing is y. So I really want this to make sense. This is truly how big the y piece is at 30 degrees. This is 1/2. It just is. This is truly how big the y piece is at 45. This is truly how big the y piece is at 60. You guys all follow? So of course, if I make a smaller and smaller triangle, the y piece gets really, really tiny until it is non-existent. And of course here, the whole damn thing is y. It's just purely y. So sine of 90 is 1, but you can also see it if I follow this pattern. Square root of 0, square root of 1, square root of 2, square root of 4 over 2 is 2 divided by 2 is 1. Isn't, now let that be beautiful, please. I'm desperately trying to help you out here. All right. I want you need to get to the point where I can just say sine of 60 and you go rad 3 over 2, bam. Cosine of 45, rad 2 over 2, bam, bam, bam. Right? Okay, maybe. So what does cosine do in the meantime? Well, cosine is easy now. Whatever sine is and cosine is, so cosine of 0, cosine likes x. So what's cosine of 0?
1.
1. Let me pick a better marker because that one, well, that was not too bad, right? That's 1. So what's cosine of 30? So it starts at 1 and it slowly decreases, right? The x piece is a little less, and then it's a little less, and then it's a little less. Do you guys? So for this triangle, it's a little bit less than here. For this triangle, it's a little bit less. For this triangle, it's a little bit less. So cosine is going to decrease at the exact same rate that sine increased. Wow. All right. I like it. Okay, good. So what is cosine? By the way, I do want to point out, I'm sure you guys have noticed right. Did I tell you about that? I had my shot. Okay. Yay. A great way to end spring break was getting a shot. Okay. So what's cosine of 30 degrees got to be?
Rad 3 over 2.
Yeah, rad 3 over 2. And of course, a cos 45 degrees is where they both agree. They're both the same. They meet. And then what's cosine of 60?
1/2.
1/2. It's crazy. And then a cosine of 90 is where it gets all scared and it's 0. Right? That's where the x piece goes to 0. There's no x piece at the y-axis. I like it. So let's extend this. What the shit? Well, what are the angles back here? The corresponding angles here. This is obviously 180 degrees. By the way, I'm still not in radians. I'm still trying to get you guys to memorize this. And then we're going to have to kind of translate to radians at some point. But for right now, I'm just focusing on the values and how they go.
It would be 120.
All right, 120.
Then 135.
135.
And 160.
No.
No, sorry. 150.
I like it. And how do I, now watch. You do not have to memorize anything past the first quadrant because it's all related to the reference angle. Aren't the triangles here? Aren't these triangles the exact same triangles as are there, correct? All right,
Yeah.
So the value of the trig function only cares about the reference angle. What the shit is the reference angle? We've talked about that at least a couple times. What is the reference angle? So what is the reference angle for 120 degrees? Let me see, what is making that horrible? It is you, isn't it? Yeah, I don't know what to do about you. Too bad.
60.
Yes, that's a little better. So the reference angle for this is 60 degrees. And then the reference angle here is 45 and the reference angle here is 30. That's all they care about. So what is sine of 120 degrees? It's equal to, and sine likes y, correct? So where's the y positive? It's positive in the first and second quadrants, correct? Sine likes y, so sine is also going to be positive. It's the x pieces here that are negative, right? the x pieces are negative, so the cosines are gonna be negative. So sine of 120 equals sine of 60. And what's sine of 60?
Add 3/2.
At 3/2. Sine of 135 equals sine of 45. So that's rad 2/2. Sine of 160. Now you got that stuck in my brain. 150 is the same thing as sine of 30. Right? That's the reference angle here is 30 degrees. Which is 1/2. That's where sine starts to get scared. All right, maybe. And of course, cosine. Now let's think about cosine. What would cosine of 120 be? It's equal to cosine of 60, but not equal directly. It's equal to negative cosine of 60. And I really want this to make all the sense of the world. The x parts are negative back here. So of course, anything related to x will be negative back here.
So -1/2.
Yeah, so this will be -1/2. I like it. And then of course, it's going to build from there. Cosine of 135 equals negative cosine of 45 equals negative rad 2/2 and so forth. All right. So there's nothing. So really, I don't have to go any further than this. I really don't have to go any further than this. Because here, what's going to be true about sine and cosine? Sine will be positive and cosine will be negative. What's true here? Sine will be
Both negative.
negative and cosine will be
Negative.
negative. What's true here? Sine will be
Negative.
negative and cosine will be
Positive.
positive. Sine likes y, cosine likes x. Cosine is positive here, negative here. Sine is positive here, negative there. What are the values? These freaking values, right? Now, can you please, I'm gonna erase all this, you ready? So what do you have to memorize? This. You have to memorize the first quadrant. Once you got that, you know everything, once you know a reference angle. So can you please draw where this angle is, figure out the reference angle, and then tell me what the value is? Cosine of what, Jeff? I don't even know. Let's do 300 degrees, sure. So just take a minute, draw where that is, figure out the reference angle, and then figure out the value of this. Don't say anything out loud.
Do you use all students take calculus?
You can. I personally hate that. I don't hate it. How do I explain this? I do
You
hate
just
it.
said you
because-
did.
I do hate it because it makes it seem as if you need it. So mnemonic devices are very useful, and they should only be used in situations where you actually need it. Here, I can base where things are positive or negative on things I already know. So what is that? So it tells me what's positive and what's negative in places, right? So all students take calculus. All things are positive here. Sine is positive here. All students take tangent is positive here. Calculus, cosine is positive there. And if it's not positive, it must be negative. Yeah, all right. If you've learned that, I have no problem with you using it. I just hate that being taught. I don't know if you understand what I'm saying, but it makes it seem as if it's required. Like you couldn't understand it without it, which is obviously bullshit, right? We know where x and y are positive and negative. Something's wrong with my video quality. I don't know what's going on. We know where x and y are positive and negative, and that's directly related to their trig functions being positive and negative. So is it necessary? No, but if you know it, you can use it. I don't care. That's fine. Yeah. Is that all right? And if you like it, you can use it too. That's fine. I just, it's a little bit of a rant of mine, or a little bit of a mission. Like, remember learning about FOIL method? The FOIL method? Anybody? It's the most worthless piece of shit that exists in the universe. It's complete shit. It is. It just is. So I'm sorry if you love it. And I don't mean foil for potatoes. Hopefully you know what I'm talking about, right? Anyway, sorry. I don't need that because it's just repeated distribution. That's all it is. I don't need this. All right, go away. Get out. That's fine though. That's fine. Okay. So who's got this? Where am I? What quadrant am I in? 1, 2, 3, 4.
4.
4.
4. So it's 300 degrees. What's the reference angle going to be?
60.
60.
Yeah, because this is 360. So it's 60 away from the x-axis. So reference angles are always the closest approach to the x-axis. Right. So once I'm like past here, I'm going to reference it to this. So reference angles are always between 0 and 90. And that's why we only have to memorize stuff in the first quadrant, because it goes from 0 to 90. So this reference angle is 60. So this equals, does it equal cosine of 60?
Yes.
Yes, good, because cosine's positive over here, isn't it? X is positive, cosine's positive. So then all you got to know is what cosine of 60 is.
Rad 3/2.
So you ready for my shortcut? Here's what I think in my head when I see this, because I actually don't have this memorized. I really don't. I honestly do not. So what I think is 60 degrees. Is that closer to Y or closer to X?
To Y.
Why?
So anything that likes X is going to be tiny. It's going to be scared up there, right? This is its home. It gets up here and it's like, oh shit. I always, so I think of trig functions as turtles, but you don't have to. I see them like getting, oh shit. You know, it's not like the percentage of the head. That's anyway, sorry. Okay. So let's try something we haven't done yet. Same question. What is the cosecant of negative, sorry, negative 210 degrees? And real quick, while it's in my brain, did you guys notice I have posted the part 2 of the homework? So the schedule for the rest of the semester is up there. I've
Yeah.
pushed the next quiz back to next Monday, just because I try to be nice sometimes and see how it feels, and it always feels icky, but I still want to try. All right, now somebody who hasn't said anything yet, because I know everybody's here right now. What quadrant am I in?
2.
You said stuff, Rio, be quiet. So yeah, you're in the second quadrant. What's my reference angle? Somebody else. Because what's this?
Negative 180 or 180.
I like, well, negative 180. That's perfect. So then how much further do I have to go to get to 210? I've got to go 30 more, right? You guys, everybody out there okay? And that's all there is to figuring out reference angles. That's it. How did I know to put it here? Because I knew it was 30 past 180 when I went to draw it. So I sort of figured out the reference angle before I drew it. It's 30 past 180. So I know where to put it. So now this is equal to, now what is cosecant? What is cosecant? What is that related to? Anybody remember? What does little robotic mean?
I'm being a little robotic.
The stream is a bit robotic.
Oh, shit. All right, so it is my Wi-Fi is freaking out. Okay. All right.
Inverse of sine.
Sorry, say again.
Is it inverse of sine or cosine?
Don't say inverse. I know what you mean when you say inverse, but it's reciprocal, right? Because inverse kind of means inverse function, which is something else entirely. But it's the reciprocal of sine. So look what I can do. This is equal to this directly. So everybody with me? Yes, cosecant is 1 over sine. And what did we just figure out? Negative 210 has a reference angle of 30. Is sine positive or negative here?
Negative.
Positive.
Yeah, sine is positive here, right? Because y is positive. So this equals 1 over sine 30. And what is sine of 30 degrees? It's closer to the x, sine likes y. So this is going to be where sine is
Half.
a half, tiny. And what's 1 divided by a half?
2.
2. Shit. All 1 divided by something means is reciprocate that. That's all it means. 1 divided by a fraction is the reciprocal of the fraction. No? Yeah, maybe. Because how do you, 1 divided by a fraction is 1 divided by the fraction is 1 times the reciprocal of the fraction. So screw all that shit. 1 divided by a fraction is the reciprocal of the fraction. That's what it is. So 1 divided by half is 2 over 1. Okay, maybe. Why do I stop and tell you that? Because it's going to happen often enough that it's good to know. Okay. All right. Let me think. What time we got? Okay. I'm going to erase this here. So speed round. Take out a little sheet of paper. All right. This is totally up to you to be honest about this. All right, so I'm not going to do any reference angle stuff. It's just purely first quadrant stuff. All right. So see if you can do this quickly. What is cosine of 45 degrees? Write it down. Done. All right. What is sine of 60 degrees? All right, done. What is tangent of 30 degrees? We haven't talked about tangent yet, but you know what tangent is. All right, who's got the first one?
Rad 2 over 2.
Yeah, 45-degree angles are awesome, right? Rad 2 over 2. Who's got the next one?
1/2.
No. So remember, I don't have these memorized. Sine likes y. 60 is closer to the y-axis, so it should be big. It's close to home, so it's coming out of its shell. It should be big.
Yeah, rad 3 over 2.
Yeah. I get. Now to do tangent of 30, I could do sine of 30 divided by cosine of 30, right? Well, sine of 30 must be 1/2. And cosine of 30 must be cosine of 30 close to x. It likes it there.
Rad 3 over 2.
3 over 2. The over 2's cancel.
Root 3 over 3.
Yeah, and then if you rationalize this bad boy, you have rad 3 over 3. I like it. So a little thing about tangent. Since tangent is sine over cosine, let me see if this makes sense. It will be bigger where sine is bigger. It will be smaller where sine is smaller. Oh, holy shit, because it's based on, bless you. It's directly equal to sine and inversely equal to cosine. So this is how I kind of
think about tangent. So sine is going to be smaller at 30. So that's why it's rad 3 over 3 at 30. What's tangent of 60? It would just be this the other way around, right? You guys with me? So this is going to end up being rad 3, which is bigger. I'm just trying to help you guys memorize these values. And you don't have to use the way I do. But sine likes 60, so tangent's bigger. Sine does not like 30, so tangent is smaller. What is tangent of 45 degrees?
1.
Yeah, because that's where sine and cosine are equal. That kicks ass. Small where sine is small, big where sine is big, 1 where they're equal because it's the ratio of the two. What is tangent of 0 degrees?
0.
0. And what is tangent of 90 degrees?
Undefined.
Beautiful. Hello. Right. Because it would be sine over cosine. Sine of 90 is 1, cosine of 90 is 0. Shit. It's all fun and games until somebody divide by 0. Creates a little black hole. Okay. All right. So you have got to either use the way I've given you, come up with your own way, something, but you must memorize these values. Right? So if I give you a problem where you have to find a reference angle and all that shit, the beginning of the problem, you got to be careful, but at the end, it's easy because you have them memorized. Okay. We will get to the point. So these are the only ones that you have to have memorized. So if I ask you what's tangent of 11 degrees, well, I got to let you plug that in the calculator, right? There's not a value that we're going to memorize. But not too long from now, we're actually going to be able to do something like this by hand. Because there's a special relationship that's called a half angle identity, which is, so half of 30 is 15. So there's a nifty little relationship there that we're going to
That kind of sounds like a spy movie.
half angle identity. Oh, I see, because of the Born identity. Probably. So it's sort of like the Born identity, just worse. I like it. You're not even a full angle. I'm half an angle. I'm doing what I can. Sorry. That was a scene from the movie. All right. I'm going to erase all this. So if I give you a problem like this, on a problem like this, I'm going to say you cannot use your calculator. What do you got, Jeff? Sure, 5. And I want to know what this is. All right, so I want to know the value of this. I want to know the exact value, right? So what trig function do I want to use?
Sine.
Sine, because I don't care about the x piece. I just care about the y piece, and I know the hypotenuse. So I want to use sine. So sine of 60 equals?
Rad 3 over 2.
I don't care. Sine of 60 from the triangle
Oh,
equals
5 over h. No, h over 5.
h over 5. I like it. Like it. So then what's h equal? Five sine of 60. And what's sine of 60? I think you gave that away. It's rad 3 over 2. So h is 5 rad 3 over 2. Bam. That's the exact answer. Any other answer is an approximation. Okay, maybe. So for on the final exam, for example, there could very well be a portion that you can't use a calculator on, a portion that you can. We'll see. I don't want to set it up. Okay. Does this make sense? Is this all right? It's the same thing that we did earlier. It's just based on an angle that we know. Okay. All right. So looking ahead a little bit. Bum, 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 bum. What was it? There was something else. Oh, that's right. Well, all right, let's talk about this. What's the biggest that sine can be for any angle? What's the biggest output for sine?
1.
Yeah, 1. That's the biggest sine can be. Because sine is a piece of a radius of 1. It's the y piece of a radius of 1. So it can never be bigger than 1. What's the smallest sine can be?
-1.
-1. It's 1 here and it's -1 there, right? At 90 and 270, 1 and -1. All right. Same thing goes for cosine, correct? Cosine lives between -1 and 1. Sine lives between -1 and 1. I like it. So very near future involves graphing these functions, not like we've sort of done on the unit circle. That's not really a graph. That's not a graph of inputs and outputs for a function, right? So we are going to graph these things pretty soon. But the last section of chapter 7 actually does something we've sort of done the whole time. They sort of throw the poor cosecant, cotangent stuff at the end, but there's no real reason to do it because they're related to, they're just reciprocal functions of the other ones. So if I want to know cosecant, I can figure out sine and then do 1 divided by that, just like we did a minute ago. So there's no reason to sort of like throw these poor things in their own little section at the end. I don't think there's anything too freaky. Yeah, this is kind of nice. Oh, let me do this. Yeah, this last section doesn't really have anything new. I'm going to go ahead and publish a couple of things. Let me show you a couple of things and then I'll let you guys out of here. All right. Let me see. Let me come back here. So I'm going to publish a couple of things in the Unit 7 module in Canvas. One is called, well, I already did the trig basics. So that's good. And the other one is called Trig Functions Unit Circle Animation. That sounds fun. So if you click on this, this is kind of nifty. All right, so this is the one I think I told you guys where I learned some trig functions that I never knew existed, and that's the versine and the x secant and the x cosecant. Don't worry about those. Those are kind of like medieval times usages. So what is going on in this image? A lot. So here's our sine and cosine. So let's start with something that really we should be very comfortable with. See how the sine is the y piece and the cosine is the x piece, and you can see it grows and shrinks. So everybody with me on that. So you can kind of focus on that piece. The cosine shrinks as the sine grows. Is everybody cool with that? You guys all right out there? Okay. But notice the tangent and the secant and all that is kind of like out here. So watch as sine grows, look what tangent does. It grows also. But do you see how it's kind of defined external to the circle? Which kind of makes sense because what's tangent? What does undefined really mean? At 90 degrees, what is tangent actually? Well, let's see. We're going to approach 90 in a minute. Where's tangent? Here comes tangent. There's tangent. Look at tangent. Look at him grow. Holy shit. What does he become right at 90? Anybody know?
Infinite?
Infinite. I love it. Let me see if I can't get back here a little bit. There we go. So there's tangent right there. So it's as long as it takes to get to the x-axis. That's what tangent is. And the minute we get to 90, it's never going to get back to the x-axis because it's going to be parallel. Let's see if you can see how it's parallel right there. I really want, this is a really cool little animation. It's nothing. If you never saw this animation, could you do trig? Yes, you could totally do trig all day long. So is this a necessary thing? No, it's just a neat thing about what does each trig function have to do with the unit circle. Cosine and sine are easy because they are the fundamental building blocks, right? They're the most easily accessible things from a unit circle. They're the x piece and the y piece. Whoop-de-doo. But then you start thinking, okay, visually, geometrically, what the shit is cosecant? Well, here's cosecant right out here. He's going to go to infinity. Wee-haw! But then he's going to come back and become -1 right there. So, all right, I think that might be enough for today. I think I've overstayed my welcome in your brain. That's a plenty for today, I think. All right, so you should be able to finish up chapter 7. Not saying time-wise, I'm just saying related to how much we've lectured on. So you're able to finish up chapter 7 now. Chapter 8 is going to get into graphing some stuff, if I remember correctly. So I've got some more cool animations to show you related to the graphs of these things. Otherwise, we're done. I'll let you guys head out. Let me know if you need to hang out afterwards.
Thanks, boss.
Anytime.
Thank
So
you.
much math I could share. You're welcome.
Sorry, I was cutting out the last few minutes because my internet isn't great.
Apparently mine isn't either. So, I mean, I understand.
Thanks for the lesson. See you
Anytime.
tomorrow.
Cool. Good.
Is the final on the paper like the correct date, or we're gonna change it, or is it the first? Like
Do you
it's
have
gonna.
a conflict or something?
No, I just want to know so I know how much time I have before the final.
It's definitely the right date.
Okay.
Yeah. Although there every now and again there's a conflict sometimes because they've only got so much time to schedule things. So just anyway, so it sounds like you're fine. So yeah, that's the right date.
Okay, thank you.
Sure. Everybody else okay?
I had a couple of questions about the midterm.
Yes.
I had a question on number 6, part C.
All right, let me look you up here. All right. Where is it? Here we go. No. All right, hold on. You push the wrong button and everything just goes to shit. Here we go. There's that thing. And let me look yours up. So what are we looking at?
Number 6, part C.
So this is the one. Oh yeah. All right. I expected more questions about this one. So let's see what you did here.
Maybe I didn't understand what it was asking. I'm not sure. I don't know what I did, to be
So
honest.
you showed it was a multiple, you showed that it worked once. Just keep going. Divide by -2 again. To be a multiplicity 2, that means that -2 works twice. So you synthetically divided once. Now keep going. Yeah.
Oh, okay.
So what
Okay.
you did was you technically showed that it works, but I didn't ask you to factor it. All I wanted to do is show that -2 had a multiplicity twice.
Okay.
Yeah, 2. Yeah.
All right, so just keep going. Okay, awesome. And then just one more, number 3, that word problem.
All right, where is it? Let's see. Here it is. Oh yeah. All right. So you have 2 variables you need to define because you have 2 numbers, right?
Mhm.
So what do you want to call them?
X and Y.
Beautiful. So your first equation becomes
x plus y equals 48.
I like it. Now I tell you, now take either one and increase it by 3 and multiply that by the other one. What expression do you get?
Do you get a quadratic?
No, just don't even think ahead. Just pick one. Which variable you want to pick?
X.
X. So increase that by 3. So now it's x plus 3.
Okay, so it'd be
So then take that and multiply it by the other number. So it'll be x plus 3 times y. Is that cool?
x plus 3 times y. But wait. No, wait, can you say that one more time? I'm still a little bit confused. Wait.
So I don't want you to multiply x and y. I want you to multiply one of the numbers by the other one increased by 3. So not x times y, but x plus 3 times y.
Okay.
Okay, I like it.
Okay.
Now there's too many variables there, but I do know that x plus y equals 48. Right?
Yes.
So can you solve that for one variable and then plug it into the other equation? And then you get a quadratic.
Okay. Okay, I think I see. Okay.
So it's sort of like an ask me, tell me.
Yeah.
It is an ask me, tell me. I tell you they add to 48, and then I ask you about the product.
Okay.
So it's exactly what it is. So I want to use what I'm told in what I'm asked.
Okay.
Yeah.
Okay, cool. I'll work on it. Awesome. All right. Thank you.
Just to give you a little clue, you should end up with non-whole numbers. It should be like something 0.5.
Okay, cool.
Yeah. All right.
All right. Thank you, Professor.
You're welcome. How's everybody else? You guys okay out there?
Yeah. So it's not really a question, but towards the end of May, my wife is going to be having our second daughter. So it's like
Congratulations.
May 5th right now. That's what the due date is. So I'm hoping that nothing changes.
Very
So,
true. Understood.
just want to give you a heads up in case I miss some class at the end of that.
Yeah.
So.
So just when we are approaching it, if you get any more updates, let me know, or just remind me if it seems like everything's on track.
Okay.
Yeah. Yeah. And I'll work with you on whatever you end up missing, if you do miss anything.
Okay.
Cool.
Sounds great, sir.
Yeah.
Thank you.
All right. No worries, man. All right. Mayam, you're okay? I'm going to head out. See you.
Yeah, Professor. See
Oh.
you.
You're okay?
Yeah, yeah.
Okay. I'll see you later.